Today I am discuss about the formula to calculate the distribution coefficient when the solute X is dissociated in one phase. At first I have to discuss about the distribution coefficient. What is distribution coefficient? If an excess of liquids or solid is added to a mixture of the solution immiscible liquids, it will distribute itself between the two phases so that the each becomes saturated. So according to the definitions, what's happened? The solvent A and solvent B both are immiscible in both of them, but when we add a solute X, it is distributed in both of them to become saturated. And after the saturation, the concentration of the X in solvent A, that is Ca, and the concentration of the X in the solvent B, that is Cb. If Ca and Cb are the equilibrium concentration of the substance in solvent A and solvent B, then the equilibrium expression, that is distribution coefficient, or K, stands for Ca by Cb. Now I am discuss about when the X is dissociated in one phase and undissociated in another phase. So X is undissociated in the solvent A and dissociated in the solvent B as Y and Z, and the degree of dissociation of the X is alpha. And the equation X is equal to Y plus Z. The initial concentration of the X, that is Cb, and in both of Y and Z, this is 0. After the equilibrium reach, then the concentration of the X in the solvent B, that is Cb 1 minus alpha, and both are Cb alpha and Cb alpha. Cb is the total concentration of the X in the solvent B. In that case, the ratio of the undissociated species in the solvents, that would be constant, and the distribution coefficient for this case, this K, is equal to Ca and Cb 1 minus alpha, where the Ca stands for the undissociated form of X, or the concentration of X in the solvent A, which is undissociated, and the concentration of the X in the solvent B in dissociated form. So that is the distribution coefficient in the solute is dissociated in one phase.